This is lecture 72A, Iran's journey from primitive communism, and we're going to be dealing with the Paleolithic, the old Stone Age in Iran, in this particular lecture. As you probably know, Iran is a nation in Western Asia with over 81 million inhabitants. It's the world's 18th most populous country, with a land area of 636,000 square miles, and as such is the 17th largest country in the world. It's bordered on the northwest by Armenia, the Republic of Azerbaijan, and the Azerbaijani enclave of Nakhchivan. To the north, it is bordered by the Caspian Sea, and to the northeast by Turkmenistan. To the east, Iran borders on Afghanistan and Pakistan, and its south is the Persian Gulf and the Gulf of Oman. Iran borders to the west on Turkey and Iraq. Thus, Iran's central location in Eurasia and Western Asia and its proximity to the Strait of Hormuz has given it geostrategic importance for millennia. Tehran is the country's capital and the largest city, as well as its leading economic and cultural center. Taking a quick look at the geology, Iran has three southern, central, and northern main separate structural units sutured by ophiolite rock. These are subdivided by structural style, crustal character, basement age, consolidation, intensity of formation, and magmatic criteria. The southern unit has a Precambrian crystalline basement and a platform-type Paleozoic development comprised of the Zagros folded belt in the southern and southwestern parts of the Zagros Mountains. It was part of the Arabian Plate. The central unit makes up central Iran and the Alborz, and was made of Cambrian, Ordovician, Silurian, Devonian, which I abbreviate as COSD in your textbook, fragments originally near the Arabian Plate. These then detached from Gondwanaland in the Mississippian and Pennsylvanian times. Submerged, they were carried northwards, impacting and attaching the Eurasian system of Laurasia in the late Triassic. These fused fragments are really microplates. They made the Iranian plate that joined the Afro-Arabia plate in the late Cretaceous. As Afro-Arabia moved northwards towards Eurasia, the Arabian plate ultimately collided with the Iranian plate in the Miocene. The North Iran suture separates the northern unit from the central unit. It's made up of continental crust with remnants of former Paleozoic oceanic crust. It also represents a marginal strip of the Hercynian realm of Central Asia that broadly overlaps the Alpine portion. It was deformed and largely consolidated by early Sumerian folding and late Alpine folding, and it makes up the South Caspian Depression and the Kopet Dag mountain range. These three main structural units are divided into some smaller geological and structural subdivisions, and these are units labeled as Zagros, Sananjaj, Surjan, Sahan Basement, volcanic belt, the Sahan Basement volcanic belt that stretches into central Iran, eastern Iran, southeastern Iran, or Makran, Kopet Dag, Alborz, and Azerbaijan. Now, major geological periods and their magmatic rocks are present: the Precambrian, Paleozoic, Mesozoic, and Cenozoic. In terms of its physical geography, geographically, Iran is located in West Asia, borders the Caspian Sea, Persian Gulf, and the Gulf of Oman. Its mountains have developed to shape both the political and the economic history of the country for several centuries, and the mountains enclose several broad basins on which major agricultural and urban settlements are located. Until the 20th century, when major highways and railroads were constructed through the mountains to connect the population centers, these basins tended to be relatively isolated from one another. One major town dominates each basin with economic relationships with hundreds of surrounding villages. People move seasonally between the mountains to the basins with their herds of sheep and goats. Accordingly, they have summer and winter pastures and accompanying transitory camping areas. Iran has no major river systems, so historically transportation has been by caravans, following roads through gaps and passes in mountains that otherwise block access to the Persian Gulf and the Caspian Sea. There, ships carry people and cargo to more distant parts of Persia and her neighbors. Iran shares its northern borders with three republics, Armenia, Azerbaijan, and Turkmenistan. These borders extend for 1,200 miles, including 400 miles of water along the southern shore of the Caspian Sea. Iran's western borders are with Turkey in the north and Iraq in the south, ending at the Arvan Rud. Now, the Persian Gulf and Gulf of Oman littorals from the entire 1,100-mile southern border to the northeast is Afghanistan, to the far south lies Pakistan, and the diagonal from Azerbaijan in the northwest to Sistan and Baluchistan in the southeast is about 1,450 miles. Iran has an arid but varied climate in which most of the relatively scant annual precipitation falls from October through April. In most of the country, yearly precipitation averages 9.8 inches or less. In the northwest, winters are cold, with heavy snowfall, and sub-freezing temperatures occur in December and January. Spring and fall are relatively mild, while summers are dry and hot. In the south, winters are mild and the summers are very hot, having average daily temperatures in July exceeding 100 degrees Fahrenheit. On the Khuzestan plain, the summer heat is accompanied by a high humidity. Major climatic exceptions are the higher mountain valleys of the Zagros and the Caspian coastal plain, where precipitation averages about 20 inches a year. In the western part of the Caspian, rainfall exceeds twice that amount and is distributed evenly through the year. Some basins of the central plateau receive 10 centimeters or less of precipitation, however. Now, in terms of the biogeography, forests cover 7% of Iran, from the mountain slopes of the Caspian Sea to the oak, ash, elm, cypress, and other inland trees. And they are on the plateaus with their scrub oak and cultivated orchards. Scattered amongst them are the poplar, willow, walnut, beech, maple, and mulberry groves. And there are 5 principal types of forest in Iran, and I won't go through them here, but you'll see that they are Caspian forest, limestone mountains, pistachio forest, oak forest, shrubs on the desert districts, and 2,000 square miles of subtropical forests along the southern coast. Wildlife of Iran includes bears, gazelles, wild pigs, wolves, jackals, and panthers, Eurasian lynx, and foxes. Domestic animals include sheep, goats, cattle, horses, water buffalo, donkeys, and camels. Birds include the pheasant, partridge, stork, eagles, and falcon. Many species have become extinct since the Pleistocene, but there are still brown bears in the mountains, wild sheep and goats, gazelles, Persian onagers, that is wild donkeys, wild pigs, Persians, leopards, and foxes across the entire country. Domestic animals include sheep, goats, cattle, horses, water buffalo, donkeys, and camels. Now we come to the primitive communism of the lower Paleolithic period. Now, Homo had to have passed through Iran by 2 million years ago to reach the Himalayan foothills by that time. What we have so far are lower Paleolithic sites in Iran that are at least at that early, and as follows. The Kashafrud Basin contains archaeological sites with the lower Paleolithic. Oldamon artifacts that are the oldest known evidence for human occupation of Iran are diagnostic here. These stone tools are made of quartz. The first core and flake stone tools were originally collected in 1974-75, and then I give the citations for the references of the archaeological studies. In a survey of the Kashafrud Basin, they are located 30 miles southeast of Mashhad, a few miles from the main river, and these investigators recognized 3 major alluvial units in the basin, which they named Units 1, 2, and 3 from the top to the bottom, and they attributed these geologic units to the lower, middle, and upper Paleolithic. Now, Darban Cave is a lower Paleolithic site in the Gilan province, that's Gilan, in northern Iran, located on the north side of the deep tributary canyon of the Siarud River. Now, Siarud is a tributary of the Safed Rud River that flows into the Caspian Sea. The cave contains prehistoric human cave occupations during the lower Paleolithic. Stone artifacts and animal fossils were discovered by a group of Iranian archaeologists of the Center for Paleolithic Research of the National Museum of Iran. and ICHTO of Gilan. The sites date to the late Middle Pleistocene period. To the west of Darban Cave is the Ganj Par Terrace site, also of Lower Paleolithic in Gilan province. It is an ancient terrace of the Safed Rud River, discovered by a team of archaeologists from the Center for Paleolithic Research in 2002. They uncovered 150 stone artifacts including hand axes, cleavers, a pick, choppers, and smaller flake tools made of limestone, igneous rocks, and sandstone. The researchers note similarities between these Acheulean stone tools and those found in the Caucasus region. Now, Feridun Biglari and Sonia Shidrang have studied the lithic assemblages of at the National Museum of Iran, and they published a general synthesis of the Iranian Lower Paleolithic, including the most recent findings in 2006, entitled The Lower Paleolithic Occupation of Iran in Near Eastern Archaeology. That's a journal, and I give the references. I've taken the liberty of citing an extensive portion of their excellent report with only editorial changes to fit our format. So to begin with, we have this Lower Paleolithic synthesis. Since the 1960 discovery of a biface on the terrace of the Karasu River in the intermontane valley of Kermanshah, at least 10 localities or groups of localities that can be assigned to the Lower Paleolithic period have been recorded in various parts of Iran. These localities include gravel deposits along the Kashafrud River in northeast Iran, the Karen, Kargar, Mashkid, and Ladiz rivers in the south and southeast, the Sefidrud River in the north, Mahabad River in the northwest, and a cave site in western Alborz, and some surface assemblages and isolated finds from various parts of the country are made a part of this Lower Paleolithic grouping. In general, these Lower Paleolithic sites are associated with waterside locations such as river terraces and lake shores, although there are some sites on hilly terrains with raw material outcrops. The waterside locations were not only important as water sources, but also for other essential resources such as raw materials, gravels, plants, and game. The known sites are usually produced small surface assemblages in each site. Artifacts number fewer than 100 to 150. Only a few sites have yielded larger numbers of artifacts. These are large and extended workshops associated with raw material sources, and unfortunately, with the exception of one cave site, none of these sites have produced animal remains or other evidence for the subsistence activities of these early hominids in Iran. Thus, our brief discussion is essentially limited to stone artifacts, stone artifact assemblages. For other aspects of Lower Paleolithic occupation, evidence from elsewhere in the Old World has been used. Now, it is feasible that Iran, like some other parts of Southwest Asia, was first colonized during the Palaeolithic period. We do not have enough evidence to determine environmental conditions and climatic changes during early hominid expansion in the region, and you can see that this is early Homo erectus. But it is clear that such environmental factors had a significant effect on the availability and variability of floral and faunal resources, which in turn affected distribution and survival of the hominid populations in the region. Grassland-type vertebrate fossils from the late Miocene localities of Marageh in northwestern Iran indicates the presence of a savanna landscape 9.5 to 7 million years ago. Now, these localities also yielded some fossil hominids belonging to Mesopithecus pentalict, which is going to be an early forerunner of Homo. Later in the Pliocene period, Iran was part of an extensive grassland belt that extended from Africa to East Asia. During the Paleopleistocene and Lower Pleistocene, these grasslands were still largely present. It seems reasonable to suppose that early hominids that expanded eastward could survive in this region since it had an environment similar to their African homeland. This early wave of hominids had simple core and flake industries, as evidenced by stone assemblages excavated at the Palaeopleistocene site of Dmanisi and at some other sites in Levant and Pakistan. That Dmanisi site is in the Caucasus. Probable evidence for this early population includes sites in the Kashafrud Basin in northeast Iran, where late Pliocene and early Pleistocene exposures are widespread. And these sites were discovered and sampled in 1974 and 1975 by Thibault and Arai, and I give the references. In the course of their survey of the Kashafrud Basin, they are located 30 miles southeast of Mashhad, a few miles away from the main river course. Thibault and Arai recognized 3 major alluvial units in this basin, and as I say, these have been attributed to the lower, middle, and upper Pleistocene. The type section of Unit 1 near Abravan is a 30-meter thick accumulation of alternating layers of gravel and sand. All artifacts were collected from the surface of Level 1 and from the eroded talus slope of gravel Level 3. The artifacts from the surface were abraded, while those collected at the foot of the section under Level 3 were in a fresh condition, which may indicate that they originated from Level 3. This presence of gravel layer, Layer 3, overlying a thick sandy layer, is interpreted by the investigators as evidence for the presence of a vast and shallow lake that gradually filled the basin in the late Pliocene. The localities in the Kashafrud Basin collections yielded 80 pieces of artifacts that come from 7 sites, all of which are now housed in the National Museum of Iran. The Abravan site yielded the largest collection with 39 artifacts. Other important collections are Chahak with 9, Bagbagi with 4. There are 4 more collections with no clear provenience from east of Mashhad, and a small collection of 4 artifacts from other occurrences. Biglari's reexamination of the Kashafrud collections revealed that some of the claimed artifacts are in fact natural objects, quartz pebbles, cobbles, or fragments with no clear human modification except for some fracture surfaces with irregular scars that could have been the result of fluvial mechanical action, or which could have been the result of humans just picking up a pebble and using it as is. At any rate, quartz pebbles and cobbles are more abundant in the gravel of Unit 1 and Level 3. Because quartz is brittle and thus more easily chipped than other rock types, it was preferred, although volcanic rocks such as andesite were also present in the gravels. This rock type usually produces flakes with a sharp edge, which is very effective for cutting. And because of quartz's friable nature, producing flakes with it requires experience and control. Its use indicates that early tool makers at Kashafrud were skilled and had good knowledge of quartz fracture mechanics. The assemblages are homogeneous in technology as well as raw material type, and they include cores and core forms, core choppers, whole flakes, flake fragments, chunks of debris, and hammerstones. The presence of debitage products, that is waste from the production of various flakes, cores, and hammerstones indicates that complete reduction sequences took place on the sites that were close to the Palaeolithic of Kashafrud. The cores were knapped by direct percussion and in some cases by bipolar reduction. Those cores knapped by the direct percussion technique can be classified into one of 4 categories: unipolar, which is the dominant category, multiple, discoid, and indeterminate. The cores vary in size between 30 and 94 millimeters with a mean of 60 millimeters. They frequently show fewer than 5 removals from unprepared platforms that are mostly natural surfaces with appropriate angles. And those of you that have been following this series know that this is very typical of the Oldowan at a certain stage. So these people brought that technology directly from East Africa. An abundance of raw material in the local gravels may account for the low degree of core reduction. As mentioned above, one of the techniques used to extract sharp flakes from pebbles is the bipolar technique, where the napper sets a pebble on a flat rock, which he uses as an anvil, and hits it from above with a hammerstone. This technique helps the toolmaker to produce the largest flakes possible from the pebble. It is especially useful when a pebble is too small or rounded to hold in one hand, as was the case at Cashafruit. There is little evidence for secondary modifications of the artifacts, and most important tools were probably simple flakes that provided a useful sharp edge. A few modified tools could be classified as scrapers, notches, and awls, and some core forms could have been used as choppers. Ari and Thibault compare the Cashafruit industry with final Oldowan assemblages from East Africa, attributed to the Cashafruit industry to the pre-Acheulean. The composition and characteristics of the industry, such as a high percentage of single platforms, including core choppers, moderate numbers of bipolar cores, the casual nature of retouched artifacts, the dominance of a single raw material type, and the high number of cortical elements resemble both East African Oldowan assemblages and those from the West Asian sites such as Demonsi in the Caucasus. I have carefully examined the 12 drawn Lower Paleolithic artifacts, and both of the photographs provided in the Biglari and Shidrang 2006 paper quoted herein, and in my opinion these are clearly Oldowan and early Acheulean typologically, and therefore the chronology is correct. So to continue, Hume in 1976 identified a Lower Paleolithic core and flake industry for the southeastern region of Iran based on lithic assemblages collected on gravel terraces of the Ladiz, Mashkid, and Samish rivers in the Sarhed Plateau between 1966 and 1967. Now, during surveys in the Ladiz Valley, 7 localities were reported on the river terraces at an altitude of 4,650 feet above sea level, and 10 more localities were recorded along the Mashkid and Samish rivers, 3,850 feet above sea level. The type assemblages for Ladizian industry come from 2 localities along the Ladiz River that, according to Professor Hume, are undisturbed or only slightly disturbed occupational floors. This is demonstrated by presence of some refitting groups from the sites, one of which includes a core and a substantial number of flakes, revealing a nearly complete reconstruction of a cobble. The most common rock material employed was quartzite, although chert and jasper were also used somewhat. Now these rock types are local and obtained from gravels along the rivers. Unipolar cores are the most frequent core types, followed by other types such as those with double, irregular, or multiple platforms. The bipolar technique is applied on chert and jasper nodules that are small in size. Tools consist of various types of scrapers, notches, denticulates, points, simple burins, and borers. Now some of these tools show bifacial retouch along their edges. Core choppers also occur in the industry, although in low frequency, based on the geomorphologic context of the localities and the typotechnological characteristics of the assemblages. Hume suggests that the Ladizian industry was produced between the late Rhys, early Würm glacial periods, that is, between 130,000 and 110,000 years ago. But this chronological framework has been criticized because it is based on the traditional Pleistocene glacial sequence of Europe. According to Professor Smith in his 1986 paper, if it is demonstrated that the Ladizian industry belongs to a terminal Middle Pleistocene, early Upper Pleistocene period, dating to marine isotopic stages 6 and 5, we may assume it is an early Middle Paleolithic industry with some affinities with industries from the Indian subcontinent. Thermoluminescence dates available from the Middle Paleolithic site in western Rajasthan, 40,200 miles east-southeast, indicate a terminal Middle Pleistocene to early Upper Pleistocene age, that is 150,000 to 200,000 years ago, for its lithic industry, according to Professor Misra in his 1989 paper. Now, Ladizian and northern Indian industries are used also as similar raw materials, and they contain similar tool types. Although Hume did not mention the use of the Levallois method in the Ladizian industry, it is represented in some surface occurrences on the Makran coast, 240 miles to the southwest, in association with denticulate pieces and core choppers, according to Vida Finch and Copeland in their 1980 paper. An industry similar to the Laodicean has been reported from some surface localities at Cache Valley that are located about 90 miles to the south of the Laodice Valley, and I give the references. Most of these localities are associated with raw material outcrops and seem to have functioned as workshops. Probable evidence for late Lower Paleolithic occupation also comes from the Mainab region in southeastern Iran. In 1977, a joint French-Iranian team led by Thibault collected some lithic assemblages on the surface of terraces 18 feet above sea level, spreading at the foot of the Zendan Range north of Mainab, which are attributed to the Paleolithic and Epipaleolithic period. The area that is located between the Zendan Range and the Strait of Hormuz coast is characterized by quaternary alluvial deposits stratigraphically organized in a four-level sequence that is dissected by the drainage network of the Kargar and Karan rivers. On the highest level of the Kargar and Karun rivers, 4 Lower Paleolithic lithic samples were collected that consist of 51 artifacts made from quartz, radiolerite, and volcanic rocks. The collections include flake fragments, cores, and tools such as side scrapers, denticulates, and notches, and one partial biface. Debitage products are generally small in size, and cores also have small dimensions. Nearly half of the assemblages are composed of cores that generally have few flake removals and platforms that lack any preparation. The partial biface, that's in size is 12 to 9 millimeters, made from grayish-green volcanic rock, had some retouching on its right and distal edges at one face and 3 large removals on the other face. The retouching on the distal part resulted in a transverse edge resembling a cleaver bit. The proposed age for the Mainab occurrences on the highest terraces places them, like the Laodicean industry, within the new chronological framework of the regional Middle Paleolithic. According to Regard and colleagues in their 2005 paper, the highest terrace on the Kargar and Karun rivers may have formed during a humid period corresponding to the deglaciation between isotopic stages 6 and 5e, before the onset of the last interglacial conditions. New dating methods used for Middle Paleolithic sites in Western Asia and South Asia specify that the Middle Paleolithic began sometime between 200,000 and 250,000 years ago, which agrees with new dates from the European Middle Paleolithic, although we should not dismiss the possibility that in some areas the Lower Paleolithic tool traditions persisted well into the late Middle Pleistocene and even into the last interglacial. One of the proposed routes of hominid entry into Iran is from northern Mesopotamia and along the southwestern foothills of the Zagros Range. According to Rolland in his 2001 paper, some have suggested that the Lower Paleolithic groups penetrated only rarely into the Zagros or beyond it to the Central Range. And I give those references, but the recent discovery of a probable Acheulean occurrence on the western edge of the central Iranian Kavir Desert suggests that the Zagros mountain range was not a major barrier to population expansion into central Iran during the Lower Paleolithic period. The Geleh site, G-E-L-E-H, is situated 6 miles northwest of Kashan at an elevation of 1,100 meters above sea level at the opening of the narrow side valley of Tang-e-Kozak on the eastern slopes of the Carcass Mountains. The site is limited to the east and west by 2 shallow stream beds that lead to the main stream channel running to the Kashan Plain. A dense scatter of angular rocks that are mostly trachy andesite covers the area. The outcrops of this igneous rock are located along northern margins of the valley overlooking the area. This site was recorded by Biglari and Haydari during a preliminary Paleolithic reconnaissance of the Kashan region in 2003. 7 large flakes were collected in an area stretching along the left side of the main stream channel and measuring approximately 100 meters in diameter. A second survey of the site by Biglari in 2006 revealed an additional sample of 23 artifacts from the same area, and this sample consists of large flakes, unifacial hand axes, and a few large cores. One is 27 centimeters in length. The artifacts are all made of altered trachy andesite and are generally larger than 10 centimeters. There was no smaller debitage, suggesting that the lighter specimens were washed away during seasonal floods of the Tangi Kozak. The main characteristic of the Gela industry is the production of large end and side struck flakes that mostly have no bulb or have only ambiguous bulbs. A few collected cores are also large, that is between 16 to 27 centimeters in length. Now, no effort was made to shape the flakes after detachment, and only a few show some partial retouch. Generally, the industry is dominated by primary stage reduction pieces that suggest Gela functioned as a workshop. Aside from sources of the raw material, the abundant springs in the vicinity, which is evidenced by travertine formations, probably attracted hominids to the area. These are Homo erectus, early ones. The presence of large unifaces made of side-struck flakes, cleaver-like flakes, and a large broken biface with steep retouching along its lateral edges makes it likely that the Gela industry is part of the Acheulean industrial complex. There is more evidence for Lower Paleolithic occupation in the mountainous regions of northwest and western Iran, where environmental conditions may have been more favorable for hominid occupations than dry regions of central and southeastern Iran. This evidence comes from three regions, including intramontane valleys and foothills of the western Zagros, east and south of Lake Urmia, and the western Alborz Range. Now, as mentioned earlier, the first recorded Lower Paleolithic find in Iran comes from the west central Zagros, where a team directed by Braidwood in 1960 undertook a prehistoric archaeological survey in some intramontane valleys in the Kermanshah region. During a survey of the hilly area of Agakia, about 10 kilometers to the east-southeast of Kermanshah, on one of the lower terraces of the Karasu River, at an altitude of about 1,260 meters above sea level, a biface was found in association with numerous flakes and cores. The cores and flakes were assigned to later periods based on their technotypological characteristics, as explained by Singer and Weimer in 1978. The biface is 16.5 millimeters in length and has an almond, like an almond nut, form. A new survey of the Gakia area by Biglari and Hidari in 1997, and later by the authors, demonstrated that this occurrence is part of a huge and continuous scatter of flint artifacts that are associated with radiolarian chert outcrops. The workshops and chipping floors relate to the manufacture of flint artifacts during different periods of prehistory, of which Middle Paleolithic artifacts are the most common. Surveys of a hilltop located 3 miles north of the Handax find, west of the village of Gakia, revealed some core choppers and numerous level wall cores and flakes, and lithic artifacts dating to the Chalcolithic, Bronze Ages, and then I give the references. The Gakia chert outcrop extends 15 miles southeast to the vicinity of Har Sin, where a survey by these authors in 2006 revealed 2 bifaces in association with level wall cores and debitage and other Middle Paleolithic artifacts. One of the bifaces measures 85.8 millimeters in length and has a cortical butt. The other is larger, 127 millimeters in length, and made by large removals over one face, while the other face bears a few large retouched scars. Both are made on local chert nodules and are heavily patinated. Association of these bifaces with level wall elements makes it somewhat difficult to determine whether they belong to the Acheulean or Mousterian industries, and they may be transitional. It should be noted that in the Zagros Mountains, assemblages discovered so far in caves and rock shelter sites, there are only 2 known bifaces. These were found by Professor Garrett in association with Middle Paleolithic assemblages from Azar Murd Cave in Iraqi Kurdistan. Now, on the level wall technique, There is an excellent moving picture diagram of the technique at Wikipedia under the heading of the level wall technique, and you should watch it to see how this industry is so distinct. A core is first prepared, and once it has been, a striking platform on one end is made. When a blow is struck, directly or via a punch, the outer surface of the core is removed as a flake that has a tortoise shell cross-section. Now back to our story, and more from the Zagros. The closest analogs to Gakia are found in the similar surface scatter of artifacts associated with raw material sources in the southwestern foothills of the Zagros Mountains, 90 miles to the southwest of Gakia. Amor Merdeg consists of a cluster of hills covering approximately 6 square kilometers to the east of the Kunjan-Cham River, north of the town of Marin, and at 200 to 300 meters above sea level. And these occurrences were recorded and sampled in 1999 by Big Laurie and Associates and reported in their 2000 paper. These assemblages consisted of only core choppers, flake tools, and large numbers of tested cobbles, cores, and cortical debitage. Additional fieldwork in 2001 and 2004 resulted in the discovery of 4 more bifaces and partial bifaces, some level wall cores and debitage, and more core choppers. Chert, sandstone, and quartzite cobbles were the most commonly used raw materials. They are plentiful on the hilltops. The high proportions of core choppers are made from these well-rounded cobbles, as were a hand axe and various types of cores. The hand axe has a thick proximal end that was left completely unretouched, and its distal part is triangular in cross-section. 2 of the 3 sides of the tool are partially retouched, while the remaining side was left unretouched, and it resembles most closely the illustrated hand axes from Mardabalka in Iraqi Kurdistan at the western foothills of the Zagros, and then I give those references. In both the Gakia and Amon Merdeg assemblages there are only a few bifaces and a larger number of core choppers, but no other lower Paleolithic tool and core types, such as cleavers, spheroids, polyhedrons, or core scrapers. These are usually present in various quantities in Acheulean assemblages of western and southern Asia. On the other hand, the presence of large numbers of various types of level wall cores and their products characterize these assemblages. In similar surface mainstream channels running to the Kashan Plain, they have an area covered by dense scatter of angular rocks. They're mostly made of trachyandesite. The outcrops of this igneous rock are located along northern margins of the valley overlooking the area. Biglari and Haidari recorded this site during a preliminary Paleolithic reconnaissance of the Kashan region in 2003. 7 large flakes were collected in an area stretching along the left side of the main stream channel and approximately 100 meters in diameter. A second survey of the site by Biglari in 2006 revealed an additional sample of 23 artifacts from the same area. This sample consists of large flakes, unifacial hand axes, and a few large cores, one 27 centimeters in length. The artifacts are all made of alternate trachyandesite and are generally larger than 10 centimeters. There was no smaller debitage, suggesting that the lighter specimens were again washed away during seasonal floods of the Tangi Kozak. Now, the main characteristics of the Gela industry is the production of large end and side struck flakes that mostly have no bulbs or have only an ambiguous bulb. A few collected cores are also large, between 16 to 27 centimeters in length. No effort was made to shape the flakes after detachment, and only a few show some partial retouch. Generally, the industry is dominated by primary stage reduction artifacts that suggest Gela functioned as a workshop, and aside from sources of the raw material, the abundant springs in the vicinity probably attracted humans to the area. These are Homo erectus humans. The presence of large unifaces made of side-struck flakes, cleaver-like flakes, and a large broken biface with steep retouching along its lateral edges makes it likely that the Gela industry is again part of the Acheulean industrial complex, and there is more evidence for lower Paleolithic occupation in the mountainous regions of northwest and western Iran, where environmental conditions may have been more favorable for hominid occupation than the drier regions of central and southeastern Iran, and this evidence comes from 3 regions, including the inner montane valley and foothills of the western Zagros, east and south of Lake Urmia, and the western Alborz Range. And then I give several pages of references, which I'm not going to bother with here because it's unnecessary. You'll have it in your book when you get it. Feridun Biglari is head of the Center for Paleolithic Research at the National Museum of Iran. His main research interest has been the lower and middle Paleolithic of Iran and Western Asia, and his associate, Sonia Shidrang, is a member of the Center for Paleolithic Research at the National Museum of Iran. Her research interest is transition from Middle Paleolithic to Upper Paleolithic in the Zagros and the early Upper Paleolithic of Iran, and suffice it to say that there is a Middle Paleolithic period dating 200,000 to 440,000 BP, and then I give all of the sites, and there is also an Upper Paleolithic period from 35,000 to 10,000 BP in the Zagros Mountains, and I give a bunch of the list of sites of that. And then from 15,000 to 13,000 BP is the Epipaleolithic or Mesolithic period, where hunters and fishers appeared along the Zagros Mountains, and then I give the names of the particular towns and sites. And the lower Paleolithic sites excavated at Kashafrud and Ganjpar in northern Iran confirm a human presence in Iran since the beginning of the lower Paleolithic. Iran's Neanderthal artifacts from the Middle Paleolithic have been found mainly in the Zagros region, in sites such as Warwasi and Yafta from the 10th to the 7th millennium BC. There are early agricultural communities that we're going to study in the next lecture, and they began to flourish in and around the Zagros region in western Iran, including Goga, Golan, Choga Bonut, and Choga Mish. For a full picture of the transition to agriculture, we shall pick up this subject once again in detail in the next chapter on the hilly flanks of Southwest Asia, and in the next lecture on the tribal agricultural stage and the subsequent evolution in Iran.